So for this vehicle, we're utilizing an 800-volt DC electrical bus from our battery. We're routing power to a high-voltage distribution module that was designed in-house. Power is routed to two inverters, which are feeding two brushless DC motors. Those are connected mechanically to an electric multi-speed transmission, which then diverts power to a transfer case from the original vehicle, providing four-wheel drive power to the wheels when necessary. There's also a number of ancillary components that are connected to the distribution module. We've got two electric heaters, one for the cabin, another for battery conditioning. There's an electric air conditioning compressor, as well as a DC-DC converter to provide power to 12-volt consumers, and an onboard charger that can do about 19 kilowatts. The vehicle's utilizing an onboard charger capable of AC level 2 charging. We can charge at the maximum allowed rate under the SAE standard, which is about 19.2 kilowatts, giving us the fastest recharge possible without DC fast charge implemented on the vehicle. It was a challenge for this project finding 800-volt rated accessories, connectors, basically any component suitable for 800 volts, because it's just coming kind of into the norm in the industry. So with most components out there being rated for a maximum of 600 volts, it reduced our options pretty significantly and what we could choose to utilize in this vehicle. So the 800-volt architecture for this program was driven partially by customer requirements, the desire to use a couple 800-volt motors. At the same time, due to the high power levels involved with the powertrain, it was necessary to go to 800 volts just to keep the current draw down. The battery charger was selected based on charging time. Other components were sized just to meet kind of system requirements. For the DC-DC converter, for instance, was limited options based on the 800-volt requirement, but also there was a current requirement on the 12-volt system based on kind of the large number of consumers for pumps, fans, things of that nature, as well as the original vehicle systems that run on 12 volts. The other components were really kind of selected just based out of kind of necessity. So we had a kind of heating requirement for both the battery and the cabin, but again, limited options with the 800-volt system. So one of the main challenges has been packaging of the components needed to get 600 horsepower to the wheels. So the powertrain in this vehicle was developed with a Class 8 truck in mind. So packaging from a mechanical and an electrical standpoint has been one of the main challenges regarding this project. Due to the extreme power requirements, we're running two sets of 2-aught cable front to rear, just mainly driven by the need to be able to get over 500 kilowatts to the motor inverters under peak power demand. So the motors and inverters themselves are all manufactured by Cascadia Motion, fairly power dense, but again, due to the 500 kilowatt output, it's still rather large. So replacing the engine and transmission in the Raptor, we're going to a slightly smaller unit, but it drives some unique packaging requirements. Thermal conditioning of the battery, requires both, the ability to cool it and also heat, depending on environmental and operating conditions. So there is a dedicated heater that runs on 800 volts, utilized only to warm the battery in low ambient temperatures. Basically, it allows you to get full power out of the battery, but it does require battery power in order to get you to that point. So, along with cabin conditioning, so the cabin conditioning also utilizes an 800-volt heater. That's in place of the vehicle's original heater core that was driven by latent heat from the engine. Without a combustion engine in place, we're having to find new sources of thermal energy for these systems. Additionally, the AC compressor is electric, running on 800 volts. That we had to source as a prototype component because there's not a lot on the market right now. There's not much unique about the low voltage. As far as the high voltage ancillary components, due to the 800 volt architecture, the current draw is rather low on those components, which allows us to downsize all the high voltage cabling. So even though we're more limited on component selection at this time, It does kind of enable a little bit of weight reduction and kind of space savings by going to the smaller cables. And again, due to the current draw being lower at 800 volts versus a 400 volt topology, it just helps us drive a little bit better packaging. So this battery pack is a 700 volt nominal, 800 peak pack. It's composed of the modules from 2 Chevy Volt batteries wired in series. This battery is using an AVL designed battery management system from our California Technical Center. It's a mature design using a tri-core processor. The battery management system split into a battery control unit and individual module control units. The BMS utilizes a decentralized architecture, with the battery control unit functioning as a supervisory controller which communicates with the module control units over an internal CAN bus. We also have safety-related functions for high-voltage interlock and isolation detection, as well as diagnostic functionality with plausibility checks. Additionally, there's an interface functionality for both internal communication and interface with the vehicle supervisory controller. So just to expand on the diagnostic functionality, we have both cell level, like voltage and temperature checks, as well as pack level checks for voltage, resistance, isolation, things of that nature, in addition to the state of health for contactors and additional plausibility checks. Part of the end-of-line checks before the pack left our California Tech Center, there were a number of tests done, including capacity, HPPC, and drive cycle tests. Furthermore, there were a number of lab tests that were run to ensure performance. These included capacity, hybrid pulse power characterization, and drive cycles. For the BMS, we utilize an AutoSAR-based software architecture.